which contact has to be made, and then heat that base and then put your lead wire. Then only the lead wire will melt and join both the members, like copper clad as well as this thing. Okay, fine. And then in practice, how we are doing it is, here try to understand. This is the PCB. The components are inserted. Let it be a capacitor. There is going to be one lead here, one lead here. And then what we have to do? We have to connect here. Here, normally capacitor can be, sometimes we can take it to the exact surface of the PCB and solder, or otherwise you can leave some space. Therefore, here we can, instead of soldering here as 1 and 2, we can make it as 3 and 4. Why we are doing it here is, if you are inserting this up to the surface and if you heat it, probably some damage can occur within this. Therefore, you can leave some length here, and then accordingly if you solder it here, that will not spoil the capacitor. The case applicable for even transistors, diodes and components, resistors also. Therefore, what I said, let it be lead has been inserted. Try to bring soldering iron. Bring the soldering iron and then heat it, and then try to put the lead. This is a lead. The lead tip is being applied here after heating this area with the soldering iron in the copper clad sheet. You have to raise the temperature and then only you should put the lead. Ultimately, this will spread in the whole thing. The first thing is, there won't be any lead at all. After soldering, it will try to bring a surface like this. When you remove the soldering iron, it will make a surface like this. Therefore, this shows that it is a very good contact. This is for a component which has 2 terminals. Like here, surface like this. Therefore, this shows that it is a very good contact. This is for a component which has 2 terminals. Like that, there may be a transistor. Let this be the PCB, and then these are the 3 terminals, but copper may be running here, like that, copper may be running here to other circuits, copper may be running here, other circuit. Therefore, we try to insert according to the base emitter collector of the transistor inside, and then the other side, here you have to understand that the other side, back side of the board, you have the lead, and accordingly please solder it what I have mentioned here. The same procedure, do it. The transistor is not supposed to be heated too much. It's a semiconductor, it may be spoiled. Like that, you can use it for either transistor, component, 2 leads, 3 leads. Let it be an IC. IC means you may be having eight-pin IC. This is an 8-pin IC within a PCB. So I am just referring this as copper clad sheet. This is a printed circuit board. Here only copper is running like this for other circuits. Here also, insert the IC properly, let it sit properly in the surface of the PCB, and then try to solder. Don't try to solder very slowly, because more heat may spoil the transistor, IC. It may spoil the IC. Therefore, try to quickly transfer the heat and melt it so that the contact can be made. So, take minimum time to solder. Okay? And then, coming to a transformer. This is going to be a transformer. Transformer may be having some 8 terminals leading to primary and then secondary, like that. There may be many secondaries and one primary. So this also have a lug position. If you see the bottommost portion of the transformer, you will be able to find terminals like this. When you insert it, properly insert all the terminal, let it come outside of the holes of the PCB and then try to solder it, all the terminals. Therefore, see that that is for only the people who are going to design the PCB and all. They have to see that the transformer is not kept very near to the component. The heat of the transformer may spoil it. That's why properly you have to design the PCB accordingly. When you put a component which is having more terminal, see that all terminals are inserted within the PCB and then try to solder it. Don't make dry soldering. What is a dry soldering? Dry soldering is nothing but when you solder two terminal using a lead wire, before melting, if you leave the tip of the soldering iron, what will happen is the lead has not been raised to the molten state of 200 degrees centigrade, instead 150 degree, with which the terminal cannot be really soldered well. Instead, there may be soldering may happen, but that may form a resistance. Resistance R. The contact resistance. If it is soldered properly, contact resistance is 0. If it is not properly soldered, then it may raise a resistance. When the terminal is driving a current, this IR drop will lead to poor functioning of the electronic equipment. Therefore, dry soldering should be avoided. Perfect soldering we need. And then if you have power transistors and all, what to do is power transistors need aluminum heat sinks. That is used for preventing the body of the high power transistors from reaching ambient temperature. Because any transistor, when it is run beyond the ambient temperature, it may fail. Therefore, it should be properly connected with the heat sink. Not only the heat sink, when you put the heat sink, the terminals of the transistor and the heat sink is supposed to be isolated using mica set. There is going to be a mica insulator which is necessary. So after that, all these terminals are supposed to be PCB by 3 wires, and then it should be properly soldered. And then one more thing, if you think the particular component is going to draw current in the order of 5 ampere, 3 ampere, like that, all these devices are not properly connected using a PCB. Instead, mechanically it is being fitted in metal brackets, and then the leads are taken to the PCB and soldered. So this you should understand. Like that, soldering is a very, very, very great job in electronics. The job, if a technician understands, he will be able to utilize all the important things. Accordingly, soldering may be perfect, and then equipment will definitely work. Proper current will be running from one point to another point, so that transistors will work properly, diodes will work properly, so that equipment will definitely work very well. Like that, things all are possible, but we have to see that after properly connecting all those things, we should see that the things are not falling down, and then you have to physically see that materials are not touching nearby. So if they are touching nearby, there is a possibility that the resistor leads may be touching the another resistor lead, so that short circuiting may happen. All these things properly connected, so that you have to take precaution in giving sufficient tolerance in the length of the lead before soldering, and then only we should solder. These are the things, important things you have to keep in mind before getting into soldering practice. I hope I have given all the information. All these things will be definitely useful to my viewers. And viewers, if they have any doubt, whatever they have in their mind, they can ask me very well. I'll be able to supply further information, and I'll be able to help them and understand this practice. Nowadays, this soldering is not done by manually, but of course, there is going to be one more soldering. It is called wave soldering. Wave soldering is an important industrial practice in which these type of manual solderings are prevented. Because as I said, manually when you are doing it, it takes more time. And also there is a possibility of creating dry soldering and so many things. Therefore, there is one more method, automatic soldering is called wave soldering. In wave soldering, we are creating a lead bath. We are maintaining the lead bath at a particular temperature. We assemble all the components in the PCB, and under the PCB and the copper clad side, the length of the components are being cut next to the surface, and then afterwards the PCB in an important fashion, the PCB, the copper clad side is going to be just immersed to the surface of the molten soldering liquid just for 45 seconds. When it is just made to touch and then removed, automatically all the points at the bottom side is going to be soldered. This is called wave soldering. You may be asking me how everywhere the copper, wherever copper is running, all the points will be soldered by this way. So how to prevent that? We want only the contact points where the leads are inserted in the copper PCB. That only should be properly soldered. That is possible by making it green masking. What is the masking? Masking is nothing but in copper clad sheet, wherever you think lead is not necessary to fill it up, just put green ink, which will be preventing the molten lead to touch those points. But only where you are not at all applied the green masking ink, and there only the copper will be properly soldered by the wave soldering machine. Like that, automatic soldering has started coming. Because of that, production rate will increase, the cost of the equipment will come down, manual soldering difficulties are avoided, properly dry soldering is avoided. Like that, lot of things have improved now, and present manufacture of electronic equipment, like for your information, cellular phone, you see, many components are there, many integrated ICs are there, how they are soldered properly, surface mounting device, all these things have come. So this is the basic. Our intention is in Ram's Academy, we feel that to understand the present technology, the basic foundation is a must for every engineer and every technician. If they have understood all these things, though the practice is not happening right now, if they understand this, they will be able to create, they will be able to get more latest ideas so that new equipment may follow. That is why we are giving all this information. Thank you very much for the opportunity. Thank you.